Okay, we can start. Good morning, good afternoon, and good evening, everyone. Welcome again to another LaSalle Sustainability Lecture Series. Today, we have an exciting topic titled Renovating Buildings for a Sustainable Future, Insights from TIMEPAC and RETABIT projects. I'm Aris Obando. I'm the Assistant Dean of the Research and Advanced Studies of the Gokongwei College of Engineering of De La Salle University. I will be your host for today. Together with me, we have our co-host, Dr. Ria Sumagang, Assistant Professor at the University of the Philippines, Los Baños. And along with us, we have Professor Kathleen Aviso, the Dean of the Gokongwei College of Engineering at De La Salle University. To start the program, we will start with a prayer.
Let me be the change I want to see, to do with strength and wisdom all that needs to be done, and become the hope that I can be. Set me free from my fears and hesitation. Let me courage and fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark in faith, service, and communion. Let us start the change we want to see, the change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
I can be the spark. Service and communion. Let us start the change we want to see. The change that begins in
Jesus in us.
Jesus in us.
Before we proceed with our main lecture for today, to introduce the LaSalle Sustainability Lecture Series, this would be presented by the Vice President for Research and Innovation of De La Salle University. Let's all welcome Professor Dr. Raymond Tan.
Ladies and gentlemen, good morning, good afternoon, or good evening. It's my pleasure to welcome you to this edition of the 2023 Sustainability Lecture Series. I am Professor Raymond Tan. I'm the Vice President for Research and Innovation of De La Salle University in Manila, Philippines. This lecture series is being held in cooperation with the International Association of LaSalle Universities, or IALU. This is a global network of universities with presence in the Americas, in Africa, the Middle East, Europe, and Asia. The lecture series is conducted by the Center for Engineering and Sustainable Development Research at De La Salle University, which is a comprehensive private nonprofit Catholic university in the Philippines. As the flagship LaSallian institution in this country, we are proud to say that we've grown significantly, not just as an educational institution, but as an institution that drives the creation of new knowledge through research and development. The lecture series is inspired by, firstly, Pope Francis's encyclical Laudato Si on care for our common home. This document enjoined Christians all over the world to reassess their lifestyles and adopt more sustainable practices for the benefit of the human race. Similarly, the United Nations Sustainable Development Goals set forth in 2015 17 goals that have been adapted by countries all over the world as a roadmap for development within the limits that can be sustained by the planet. Both of these documents provide basis and inspiration for the sustainability initiatives that are undertaken by academics throughout the world, including academics working within the IALU network. The Sustainability Lecture Series was initially conceived in late 2020 by a core group consisting of Dr. Kathleen Aviso, the Dean of the Gokongwei College of Engineering, Dr. Carmelita Quebenco, Chancellor Emeritus of De La Salle University, and Dr. Alvin Colaba, the Director of the Center for Engineering and Sustainable Development Research, and of course, yours truly. The lecture series deals with diverse topics in sustainable development and are mostly held on the last Wednesday of each month, streamed via Zoom and with recordings made available via YouTube. We have a dedicated YouTube channel with almost all of the previous lectures made available publicly, with a total of about 5,000 plus individual views to date. And we've drawn on resource persons from the global IALU network to share their initiatives on sustainable development. And as the world emerges from the COVID-19 pandemic, we have decided that this lecture series remains a testament to the LaSallian commitment to a greener planet. Thank you and good morning.
Thank you very much, Dr. Tan, for the introduction of the LaSalle Sustainability Lecture Series. And now we would go now to the lecture. Allow me to present to you the two speakers. We are honored to have our two speakers for today. Our first speaker is Dr. Alvaro Cecilia Gomez. He is a professor and a researcher with a PhD degree in computer engineering. He is the head of the Architecture Representation Computation Research line of the School of Architecture of La Salle Campus, Barcelona. Dr. Gomez has extensive experience in improving energy efficiency in buildings and cities through data integration using semantic web technologies. He has experience in national and European research projects related to artificial intelligence, data management, parametric design, and data visualization. Dr. Gomez is currently participating in projects such as the ReDwell and TIMEPAC, and he coordinates the RETABIT project. Has published works in the field of architecture, engineering, and construction sector. And now for our second speaker, we have Dr. Gonkal Costa Jutglar. He is a researcher in the Architecture, Representation, and Computation, ARC, research line, and a member of the Human Environment Research Group. He participated in different research projects funded by national and European programs, which he is also part of a very recent projects such as the TIMEPAC from 2021 to 2024, RETABIT from 2021 to 2024, the Accord from 2022 to 2025, and Green Twin from 2023 to 2024. He has 23 years of experience in developing software applications in different IT companies, founding startup companies and entrepreneurial projects. He has 14 years of research experience in the application of ICT in the AECO sector. His area of expertise focuses on the application of semantic technologies, ontologies, and linked buildings data. Dr. Jutlar is a member of the BIM User Group Association of Catalonia, a member of the W3C Linked Building Data Community Group, and European Network for Digital Build Permits. All industry. Join me in Dr. Goncalves Costa.
Okay, thank you. I think the last words we couldn't see, we couldn't hear well. I think it was a problem with the connection. I guess that now it's okay, the connection. So thank you for your warm words. I'm going to share the presentation. Okay, so thank you. The presentation is titled Renovating Buildings for Sustainable Future. And we will present two projects. I will present myself, the second one, RETABIT, and Gonçal will present the TIMEPAC project. Before we start, we wanted to say some words about the group, our group, Architecture, Representation, and Computation, because it's worth to mention that it's a multidisciplinary team composed of architects, computer science engineers, multimedia engineers, graphical designers. And this is important because the projects that we do for sustainability and energy efficiency always mix these two worlds: the world of the built environment, city, the buildings, the public spaces, with the world of computation. So we always try to quantify the world, just or not just, or to provide some insights or to provide some to support the decision making. And this is our core research line in our group. Okay. So, renovating buildings for a sustainable future. We start with the sustainability. So, what does it mean, sustainability? United Nations, some decades ago, they provide this definition: meeting the needs of the present without compromising the ability of future generations to meet their own needs. So this definition emphasizes looking ahead, thinking about today's action will affect the future. Also, to manage the resources that we have today in a responsible way, because the choices that we make today with these resources will affect the resources that will be available in the next years. And also, it's important to highlight that the sustainability is not only about the environment, it should include also aspects with regard social and economic. And to achieve sustainability, the whole civilization, we need strategies that balance social fairness, economic success, and environmental care for lasting harmony between human activities and the planet's ability to support life. And these strategies was mentioned before are, for example, the Sustainable Development Goals. These are a global agenda adopted by United Nations in 2015 and they set out 17 goals to achieve a more fair, equitable, and sustainable world by 2030. And if we want to focus on buildings and cities, so the building stock, the built environment in which we live and we work, then we can narrow down these 17 goals and to focus on these three. SDGs 7, affordable and clean energy. SDG 12, responsible consumption and production. And SDG 13, climate action. Here, when we talk about buildings, the buildings in which we live, they need energy, these buildings, to warm up, to warm us, or in winter, in summer, to get us colder. Yeah? So by reducing the operational energy demand, energy need of the building, and also integrating renewable sources, we can improve the level of energy efficiency of these buildings. This is the way to make us more sustainable. And also we have to consider that the new buildings that are going to be built in the next years are not important, yeah? Because they have to be built in a way that consumes few energy or zero energy and provides less carbon emissions. But the focus of today is the existing building stock, because this building stock around the world, and in particular in Europe, that we are going to talk about Europe, is a building stock that is very old and is not energy efficient. So it requires a lot of energy to live there in a comfort way, yeah? And much more important, those buildings that we have now that are 80, 70, 60 years old, the next decades, they will be there. So we need, and we cannot demolish and build again, yeah? Doesn't make sense, yeah? But we need to improve these buildings to have and to make them sustainable in the use and also in terms of the use of natural resources. So a renovation wave is needed. So it's mandatory to renovate all the existing building stock. And now we are going to talk about Europe. Europe and other regions in the world realize this topic, that the buildings consumes a lot of energy. In case of Europe, we have there are some statistics, and they say that the buildings are responsible of 40% of Europe's energy consumption. That's a lot. And also are responsible of 36% of carbon emissions, the whole Europe. It's a lot, yeah? So the main objective of Europe, the European Commission right now, is to define long-term strategies towards carbon neutral continent by 2050. And they have approved, they are putting in place some directives, some packages, some strategies like a Green Deal, Fit for 55, Renovation Wave, just to accomplish this goal, to have the first climate neutral continent by 2050. And here the issue is that right now, only 1% of the buildings are renovated every year. Renovated in terms of that they consume much less energy than before the renovation. And this is a challenge that we have among us, to increase this renovation rate in several points, just to meet this objective to be a climate neutral continent by 2050. So this is the challenge that we have, and this is the research that we are doing in the team. And we want to present now two projects that talks about this issue about renovation. First, the TIMEPAC is focused on buildings, particular buildings. And then the second one, RETABIT, is about cities, groups of buildings, neighborhoods that must be renovated as a whole. So now I give the floor to Dr. Gonçal Costa, that will explain the TIMEPAC project.
Okay, thank you, Alvaro. I will present the TIMEPAC project. The TIMEPAC project is funded by the Horizon 2020 Europe program as a coordination and support action. This project is coordinated by us, La Salle University, and is in the last year of the 3 in its development. So the project has a consortium with 14 partners from 7 countries. We have universities, certification bodies, software developers, local energy and communication agencies. So the objective of this project is to increase the quality and reliability of energy performance certificates, that is abbreviated is EPCs, schemas, using data from building information models, basically. So the idea is connecting the EPC schemas with sustainability and smart readiness indicators. So all of this is to obtain, or the main goal here is obtain an enhanced EPC. And also this project is dealing with the integration of the energy data of the different sources into the current or existing EPC databases. So the idea here is transform all the outputs of the projects into training materials and provide these materials in something that we call TIMEPAC Academy. So to fulfill these objectives, we envision 5 future scenarios to enhance the current EPCs basically in these European countries. One of them is using the data from building information models to generate the EPCs. And this is the scenario I will introduce in this presentation, but we have these other 4 scenarios. The second one is enrichment of the EPCs from operational data integration. In the third, we are considering creating building renovation passports from data repositories. Also, we are considering the integration of smart readiness and sustainability indicators in the EPCs, like another alternative or scenario. And finally, we plan using large-scale statistical analysis of the EPC databases to increase their quality. So the interesting question here, maybe you can pass to the next slide. The interesting question here is how we can generate or why we want to generate these EPCs from BIM data. So the problem is that the certificate issued to date are not accurate, so we cannot trust the data. In particular, a consultation carried out by the European Union in 2021, it said that the most of EPCs in Europe are outdated, inaccurate, and incomplete. And it means that they don't really reflect the actual characteristics and condition of the buildings. So some reasons here are that the lack of reliability and standardized of input data, and the heterogeneity in tools and methodologies in each country. For example, in Spain, we have at least 4 different official tools to calculate and issue the EPCs. So to solve the problem in Europe, we have a directive that is called Energy Performance of Building Directive, EPBD, with a new version probably coming in the next months. And this directive is intended in providing the necessary instruments to increase the renovation rates of buildings. The tools that included proposed includes level frameworks, the digital building logbook, smart readiness indicators, and so on. So all of this is to aim to decarbonize the continent during the next years. And it is true that this directive is not mentioned or is not saying nothing about the BAM, but it is true also that it seems clear that for some of these instruments, the BAM can play a key role here. So one of these instruments is the building renovation password. This instrument is a document that defines a long-term renovation. We are talking about more or less 15, 20 years. And it's based on creating a roadmap with different steps and making them affordable for the building owners. That is the most important. So the goal here is to make the renovations affordable for the owners, improve the comfort of inhabitants, and at the same time, reduce the CO2 emissions. So the first step of the process starts with an energy audit. And this from this audit, some measures are proposed and scheduled in the roadmap. For example, the first measure can say, okay, it is necessary to renovate the facade. And the second one says, okay, now in this other time, it's necessary to renovate the active systems. And then other kind of things of the building, for example, the elevators, no? Maybe are not so efficient. So then this is a roadmap that is proposed to the owners to fix the times to perform the renovations works collaboratively. So in applying the measures, the BIM can play a role to facilitate the renovation process. So the technicians can use the BIM model to evaluate the multiple renovation measures for every step, including supporting the construction process. Also thinking in the future, if new renovations have to be carried out, so the BIM can be reused and adapted with the new changes. So to summarize the current status scenario, most EPCs in Europe, countries and regions are outdated, inaccurate and incomplete. In Europe, we have this directive, EPBD, aimed to address this scenario, especially focusing on the data and their integration. And from the BIM data reusing approach, we can contribute to that in providing accurate and reliability information to reduce, or in order to reduce the human errors, data reuse and open interoperability. So regarding the implications, the BIM must exist. If not, create it involves an expensive cost, and it's probably maybe could be that have no sense to go for this alternative. So we are thinking a future scenario in which we have BIM models of the buildings, something that maybe we think that will be more usual and even mandatory for different reasons. So in particular, we think that will be necessary, considering that all the things that we can do with the BIM data for sustainability activities can justify that in the future we have these models, for example, for energy simulations, recycling materials, and these kind of things. So one important aspect of this approach is and reusing data is the open of interoperability. Here we have a standard. This is the most adopted standard to represent the information of the BIM models. That is the IFC. Is a standard supported by the Building Smart International Organization. And with this standard, it is possible to exchange BIM data between different software tools. In this case, BIM authoring tools, between BIM authoring tools and EPC generation tools. When this information can be provided in an open format. So any program can reuse or open the information in this standard and make the reuse, in this case, in the EPC generation tools. However, in this approach, there are some limitations. Not all the information required can be represented in an IFC model, since the IFC is not being designed to represent the BIM data in the way that EPC programs or energy simulations need it, but in general. So this is something that we have to take in consideration. Also, there is other limitations. For example, the IFC exporters from these authoring tools. Some of these exporters are not providing the full potential to export the information of the building in the needs that are required. So there are limitations here in the definition, also in the exportation. However, the standard is progressing with new versions to include more representations, and we hope that this, or at least part of these interoperability limitations, can be resolved in the coming years. So from all these limitations, we are providing guidelines to explain how to the users that have to use or are the ones that will be responsible for reuse this BIM data for the generation of EPCs, to explain how this open interoperability can be done, depending on the scenario, depending on the tool involved, the authoring tool to generate the BIM model, or the EPC generate tool to generate the EPC in the best way for each of the case. So most important questions here are the data requirements. So it means check that all the data that is provided in the IFC models, in one way or another, if possible, have to be that is expected have to be provided in these IFC models. If not, this information cannot be reused in the way that we are expecting. So in the guides, the process of reuse BIM is divided in six steps. We can have two scenarios here also, where the BAM model exists, but we are also considering this other scenario in which we don't have a BAM model. No, so this is the worst case scenario. In this scenario, probably we should create these BIM models according to the needs that are required for the generation of the EPCs. So in the first step, we are explaining in these guides how the model should be designed or completed with possible missing information. Most current BIM models are only architectural models, so sometimes these models have to be completed with information of the energy and also active, for example, active systems, no, or other information that is required for issue the EPC. Next, we are explaining how to provide the export, the information to the BIM IFC model. Then how the model have to be checked with the data requirements. For example, these data requirements can be checked using what we call, or what the community call, an IFC viewer that can load the IFC model, and in a 3D viewer you can see each of the parts if there is something missing or if something has to be provided in more correct way. And finally, when with this information is checked, we also explain how to import the model into the final EPC tool that will reuse the data to issue the EPC. So these are some screenshots of the guidelines that we are providing. We have planned to release this document in the coming weeks, maybe. And we expect that could be of interest for the whole community. So the guidelines have also been deployed from a series of tests with 30 BAM models from 6 countries. Most of them are residential buildings, but also tertiary-like schools and office buildings. So this slide is just to show the time invested to generate the BAM models and the data of the EPC tools. In the project, we are considering the worst case scenario in which we don't have models. So we have to generate these BAM models. So it's something that is affordable. It's true that it requires a lot of time to generate these BIM models, but in 20 hours, we can have these models generated. So it's something that can be achievable. And the BAM models are generated from the blueprints, basically, but there are also information that have to be included to generate these BAM models according to the requirements. So the different colors that we are seeing in these graphs represents each of the steps, the time invested in each of the steps. For example, the blue represents the time spent to generate the BAM models, the orange involves the analytical of the data, the gray the exportation, and so on. So one of the problems with the generation of the BAM models was in this case, in our project, was the quality of the original sources. No, for example, the blueprints. The blueprints lack of there is information that is not provided and is not accurate. So we had to do some improvements here and to retrieve information from other sites to complete these models. Some of the problem of the blueprints is that sometimes are very old, no, only contain personal information. Others contain information that maybe is insufficient, and also there is the issue of the language, because we are dealing with blueprints that are provided by countries that are defining the things in their own language. So this is also something that we have to consider, because sometimes you have to identify the proper term to perform this identification of the information. Okay, so last slide. As a result, conclusions and summary. We have developed guidelines from the designation of EPCs from BIM to explain to the public how this process can be done. If you are involved in this kind of process and you want, or you can use this BIM alternative, so this guide is for you and can help you to identify which is, in your case, the process that you have to follow. So it's important to consider the issue of the data interoperability as a key challenge. It requires collaboration, and the multiple agents of the industry have to be agree on this approach. So this involves developers, public administrations, and standardization bodies, and these kind of institutions. So the use of BIM models, we think we can improve the quality of the input necessary to generate the EPCs. And this is, for us, an improvement in contrast with the traditional methods. I think that this is all from my side.
Okay, thank you, Gonzalo. I will continue now, and I will present the RETABIT project. This is the short name. The long name is the one in the screen. Multidimensional data-driven services to foster residential building retrofitting programs in the implementation of SICAPs. So in short, what we do in RETABIT, we're providing a platform. It's an ongoing project. We are developing a platform that gathers data from multiple sources and identify where are the problems, where are those buildings that perform bad in terms of energy, and not also in terms of energy. For example, where are those buildings that have poor services, or where are those buildings in which lives people that are vulnerable in terms of several aspects. So the idea is that here, as I said at the beginning, the idea is not only to improve the sustainability of the building stock just in terms of energy, also in terms of social and environmental and economic aspects. So that's the goal of this project. We will do an holistic platform that can support urban planning of different municipalities. It's a project coordinated by us, by LaSalle, and we have one partner, which is the Catalonia Institute for Energy Research. And this project is being co-funded by the Spanish Ministry of Science and Innovation. Okay, so as I said before, the goal is to define or to develop this service platform to support the stakeholders, mainly urban planners or local authorities, to provide or to define large-scale residential building retrofitting programs, because are those buildings that should be renovated, as I said before in the beginning. So we have three steps or three actions that we can do in the platform. We can explore urban areas to evaluate the renovation potential based on several indicators. I will show you a couple of them. Then once you have detected or identified which area you want to renovate, then you can create renovation plans based on multidimensional indicators. You can rank them, and then in your municipality, as a public authority, you can start developing these plans. And then third, you can follow up the impact of these implemented renovation plans over the time. Because it's important that the sustainability is monitored over the time. This is also one of the aims of the SDGs, to monitor the targets and the goals in order to understand if we are progressing or we are not progressing. Okay, so the platform, the core of the platform is a central database in which we calculate social and urban key performance indicators, socioeconomic indicators, and also energy indicators. And this centralized database gathers data from different sources. For example, Cadastre database. Cadastre is the land registry. In Spain, we have an open database in which we have all the building footprints of the whole Spain. So in Catalonia, the region Catalonia, we have around 1 million buildings and 3 million dwellings. This is one of the sources. Other source is the EPC database. EPC database is the Energy Performance Certificate. As Gonzalo said before, a certificate is a compulsory document that you need to fulfill when you rent or when you sell your dwelling, your flat or your building, your house, and contains a lot of useful data that can help us make decisions. So we integrate this data. In Catalonia, for example, we have 1,400,000 EPCs, energy performance certificates, which is a lot. Then we have weather data, house rental prices, national statistics about who live there in the buildings and how they live, so national statistics, and other databases. So we integrated all of this data in this centralized database. It's a geospatial database indeed, that help us to draw some maps that I will show you later. And here, with these KPIs that we have collected, around 36 KPIs we have, the energy KPIs help us to detect or identify the main retrofitting needs. Then the socioeconomic KPIs help us to define the barriers, who cannot afford the renovation or who can afford it. So these kind of questions we can answer through the socioeconomic KPIs. And then the social and urban KPIs help us to identify further improvement opportunities. At the end, we have a multidimensional model for retrofitting evaluation. So what we do, so we gather this data, we de-escalate the data at building level because it's our basic unit. And I'm saying that because, for example, the statistical data usually is not at building level. It's a group of buildings, a census tract, for example. So we de-escalate, it can at building level. Then we calculate the quantitative KPIs. All of them are quantitative, so we have real values. And the calculation of these KPIs are based on the literature. So some of them, it came from the SDGs definition. And then once we have it, then these KPIs can be aggregated if we want at city level, region level, at neighborhood level to have an holistic view, a big picture about our municipality or our region. So at the end, we have a multidimensional building model, a georeference building with data about different dimensions, social, economic, energy, and urban context. So let's think about a practical question. You are a urban planner. You live in a city, you're an urban planner, and you want to improve your buildings. So, and your focus for any political reason is the one that is written in the screen. So you want to identify areas that contains low urban and poor building quality. And in these areas live vulnerable people in terms of economy, of income. Yeah? So to answer this question, we can use in RETABIT platform 2 indicators. KPI 20, the median household income, and KPI 31, the vulnerability to heat wave temperature rise. And here you have all the details, the sources and how we calculate it. And in the left side, you can see the maps. And these are, I think it's Terrassa, is one of the cities in Catalonia. And here you can see the map. So the lighter colors in KPI 20, the picture in the top, are the people who has less income, family income, and the darker has higher income. Yeah? And with regard to vulnerability, KPI 31, the lighter colors has less vulnerability, and the darker colors of purple has higher vulnerability. This vulnerability is, for example, in case that the temperature degrees increases in 1 point or 2 points. That is the scenario that we are we face in the next years. So we come back to the question, which densified areas with low urban and building quality are inhabited by economically vulnerable populations. Then we need to put together both indicators. And we do this composition, or we call it composition, in which we put together both indicators. KPI 31, which is the vulnerability heat waves, and then we negate KPI 20, because we want to highlight the people who has the vulnerable people. So we have to negate the median household income. And then in this composition, on the right, we can identify the darker areas, darker buildings, are those that has people who lives with a low household income, and also buildings that are vulnerable to heat wave temperature rise. So with this scenario, the urban planner can, for example, decide, okay, in this area, we will promote the building renovation. Another example will be this one. In this case, the urban planner thinks that now it's important to talk about the urban amenities. So we want to identify areas with limited access to green spaces, and are also or have limited access to essential urban amenities. So to answer this question, in this case, we need two new indicators, KPI 30, which is green areas. So we have calculated the number of green areas close to each building. So every building we have calculated in a circle of 500 meters. And also we did the same for the KPI 27, the 15-minute city. So we have calculated all the possible amenities, restaurants, hospitals, schools, kindergartens, around each, also public transport around each building. So now we can compose both indicators, put together both indicators, and now the urban planner can say, okay, again, in this same area as before, is again darker. So probably we need to focus on that particular area. Yeah. And then I wanted to speak briefly, because perhaps it's too technical for today, about energy. Energy data, okay, we have a lot of certificates, but not all of the buildings or the dwellings that we have in our cities are certified. So we need a way to define this certificate. So to define these indicators about, for example, energy demand, how much energy needs a building to have comfort. Yeah. So we got this database, EPC database. We cleaned this database because not all the records were okay or have all the data inside. So we clean it. And then we train a machine learning regression model with this data in order to estimate the heating and the cooling demand for all dwellings in Catalonia, which is around 3 million. So we train this regression model, and then the median absolute error that we got, so we validated, was for heating demand 14 kilowatts per square meter a year, which is it's an error that's acceptable, it's okay. And then for the cooling demand is just 2 kilowatts, which is also okay. Yeah. So with this indicator, with this process, based on machine learning or artificial intelligence, we could generate new data, because the data that we saw before is data that we have in public sources, open data, yeah, but we got it. But then for some scenarios, we need to create new data. So this is one example of how we create new data. So now we can define another scenario, yeah? Where are the locations with vulnerable population living in non-efficient buildings with limited access to green spaces? So here we cross 3 domains: energy, environmental, social, and economic. So we have the KPI 20, median household income. Now we have KPI 30, the green areas for each building. And now, as we estimate the heating demand, we have KPI 37, in which we have defined the demand for every building. So we can cross, or we can compose the 3 indicators that way. And then we have a better precision, and also we can provide an holistic view in which building should be renovated, not only in terms of energy, not only in terms of economy or social, but all together at the same time with these maps that we are providing. So now the urban planner can focus on that particular areas. This platform is undergo, so we have some mockups, and the first release will be around March in the next year, so in 3 months, and we will share with you all how is this project and this platform progressing. So for concluding, we need to make the world more sustainable. But for doing that, we need to understand how it is now and how it's progressing. For doing that, we need data. So we need data, indicators, information, whatever you want to say, but we need data. So data is important, and we need to understand that the main aspects or the main important aspects are that availability of the data, the reliability, you can trust that data or not, the maintenance over the time. So these are the main key issues, and some data are owned by public bodies, public organizations that should take into consideration those aspects that I said. Also, fostering the building renovation with sustainability criteria require to consider different domains, as I said before, not only energy or environmental, also social and also economic, and consider different scales. And for having that, we need data, and data has to be harmonized in all of these domains, which not always is the case. And also that's important if we want that those tools, those guidelines that also Gonçalo present meets the users or speaks to the users, we need to make these interfaces in a way that are not complex, that are understandable and are important for these target users. Because sometimes we are so technical, we put some kilowatt hours figures there, but at the end the user doesn't understand that. Yeah, so we need to make these interfaces easy to use to the final users. Okay, thank you for your attention, and that's it.
Thank you so much, Dr. Alvar and Dr. Goncal, for sharing your projects and your expertise today. Now, to facilitate the question and answer, allow me to transfer the floor to Dr. Ria. Dr. Ria?
Hello. Thank you so much, Dr. Alvaro and Dr. Goncal. I learned a lot about the steps that EU is doing for future proofing and to increase the resilience of cities and buildings against climate change. And I think this is a very good use of technology. I mean, all of the databases and the models and even machine learning that your project is doing. I guess we can start the Q&A. There's one question from the chat box from Professor Raymontan. Let me read it. Thanks for the talk. Do you intend to deploy these techniques commercially? If yes, how?
Yeah, thank you. Thank you, Dr. Tan. Yeah, in the TIMEPAC project, in the next 3 months, we are going to deploy the TIMEPAC Academy. So these guidelines that Gonçalo presented will be provided as courses that will be local courses in the different countries that we are partners of the project. And if this TIMEPAC Academy goes well in the next year, then probably it will be there for other kind of courses. And yeah, I guess that it will be commercially approved. Yeah, and the other project, RETABIT, is a research project, and with other partner IREC, we are defining an exploitation agreement in case that we need to do this commercialization. Yeah, this commercialization, our target are municipalities or cities, so we need to talk with them. So it's not so straightforward to do this commercialization because their funds are limited. As I guess other countries happen the same. But yeah, that's the goal. That's the goal. Yeah. Thank you for the question.
Thank you for the answer. There's another question from the chat box from Umakanta Mishra. I want to know IFC and why KPI has used. Um, Maybe what's the meaning of IFC?
IFC is is an standard that
Mm-hmm.
it enables to represent all the information of a building in the 3D and with PSETs, basically this one. But in our scenario, we are including information about the active systems, and information also about the materials, and this information that is required by the tools that are the ones that use it to generate the EPCs. So basically, this is the information that is included in these models in the IFC format.
Hey, thank you so much, Dr. Gongkal. Next question from Professor Aris. Thank you very much for the presentation. It was highlighted the importance of green spaces in urban areas. What are the strategies? What strategies can possibly increase more green spaces in these areas?
Yeah, thank you, Professor, for the question. Yeah, they are very important. Yeah, and I didn't say, but green spaces, green areas, the trees, the different green areas that we have in the cities, make our cities less warmer. And that's important because the temperature of the world is increasing. So we need to decrease the heat of our cities. Yeah. So what are the strategies? First is to identify the problem. Yeah? So which areas of my city doesn't have enough green spaces areas. Yeah? So this is the first step. And we can do that with the RETABIT platform. And then how we can change that? That's how we can do that. If we think about public spaces, then it's a matter of the municipalities that they want to change the public spaces to include more green trees or different things like that. Yeah. In terms of the buildings, then the thing that you can do is to have green roofs, which is something that is not so common, but nowadays is becoming more common. So you can renovate your building. So you renovate the facade, you renovate the systems, and in the roof, you can put
Green
some
roofs.
green gardens in a way, or other kind of green technology, in order to cold a bit the building and also the whole city. So these are the two strategies that you can follow.
Mm. Thank you, Dr. Alvaro. I think I've seen some examples of buildings with green roofs, meaning they have vegetation on the rooftop, so it helps with the cooling of the building. We
Yeah.
have another question from the audience from Anya Kalu. Thank you. How could you use these techniques in the interior design industry? How could you bring these green spaces into the interior of buildings?
Yeah, maybe Gonzalo can answer that because we have another project which is called Green Twin, in
Mm,
which we are mixing the BIM technology, the building information modeling technology, with some vegetation. I don't know if Gonzalo you can say something about that. It's a new project. It's just a couple of weeks that it started.
Yes, it's another project, but I'm not sure if it's related because we are talking about a small green a small green wall in one place in the building, and we are just collecting data to see how we can analyze of this data to generate some kind of outputs from
mm-hmm,
the IA, but we are not just considering the beam as the whole space, just this small space, and see how the contributions of the people that pass behind or in front of this green wall, but not more than this.
okay.
Yeah.
So related to that, I would like to clarify. I'm imagining that a BIM model is like a digital twin. Is that correct?
well, so.
And
To some extent.
to some extent, yes. So you mentioned, Dr. Gonka, in your slide that there's a step wherein you validate the BIM model. How do you exactly validate the BIM model?
We have different alternatives here, but one of them that I think should be the most prominent one is using this other standard of the building smart that is called IDS that allow to define requirements. So if we have clear which are the requirements for these tools, through this standard, we will be able to say, okay, this BIM model fulfill with the requirements or not, using existing tools that allow to use this IDS file with the requirements to see, okay, this IFC model fulfill with the requirements required for this EPC tool generator or not. So this can help.
I see. Okay, thank you so much. Again, we have another question from the audience from Chalmer Belaro. May you share insights from the current green building ratings available, like LEED, or is that pronounced as LEED, and what role it plays with your projects? Thank you for the talk.
Yeah, these voluntary schemes like LEED are the schemes that it takes a lot of time to pass this LEED and to have this scheme in your buildings. And as I said in the beginning, we need to renovate a lot of buildings, yeah? And we need easy tools on easy schemes, easy certification documents just to increase this renovation rate. And LEED is okay. I think it's mainly for new buildings that, of course, they are very well built. They just doesn't consume energy. Indeed, are positive buildings that produces more energy than the energy it needs. But for renovating the whole building stock that Europe wants to renovate, we need to have a not so strict voluntary scheme. For example, the energy performance certificate, which requires much less effort than the LEED to be succeed.
I
Thank you.
see. Thank you so much. For the interest of time, we will be entertaining one last question. So, to the audience, you may type in your question or you may unmute yourself if you want to ask your question directly. So, I guess I would ask the last question, and then afterwards, I'd like to ask our speakers for any parting words for the audience. The last question is for Dr. Alvaro. So you mentioned that you have like 36 KPIs for the RETABIT project. So among those 36 KPIs, what do you think should be prioritized, and why should it be prioritized?
I don't have the answer. It depends.
Okay.
Depends on your
Depends.
needs and not the needs of your politicians, the need
Mm.
of your local authorities. So it depends. And that's important, yeah, because we have provided, or we are right now providing 36 or 37 KPIs, but we will let the user to define their targets.
Okay.
The questions that I put in the slides are the questions that the user can make to the system, to the platform. The platform will have like a chatbot in which the users can make the questions, and then the platform will say, okay, according to this question, I think that you need KPI 1, 10, and 30. And we will have a dialogue in which this KPI selection will be made together with the end user, with the urban planner who has the goals in their head, and the system. So it's not just one single
Just one.
answer. Depends on the user, yeah?
So it's a case-to-case basis, and it depends on the user. All right, so thank you so much, our speakers. Now I'd like to ask each one of you any parting words for the audience. So something that they can think about over the weekend.
Okay. I think the important thing here is that we need to be more sustainable. In our presentation, we need to renovate buildings. All the buildings should be renovated because we live there. So, okay, it's expensive to renovate buildings, a lot of expensive, but we live there, we work there. So it's better to have a better buildings to be used by us. And for doing that and to make decisions, we need data. That's important.
Data.
Yeah, we need to data. We need to curate the data. We need to calculate good indicators. So that's my takeaway. Yeah.
Dr. Gonkal, and do you have anything to add?
Well, in the same line, more or less, but maybe we should have in consideration that we have to put more attention in maybe the actors that have this prominent option to take all of this and convert this in a reality that maybe are the administrations. I think that we have to push the administrations, involve the administrations in all these projects and make them collaborative, and try to help them to materialize all of this. I think that maybe this is one of the points that we have to move on in the coming years.
Thank you so much. So my key takeaways is first, you need data in order to do the steps for sustainability, and you also need to influence the actors, the ones who make the decision on these things. Again, I'd like to turn the floor back to our host, Dr. Aris. Thank you so much.
Thank you, Dr. Ria, for facilitating the Q&A session. And also to our speakers, Dr. Alvaro, Dr. Gongkim, your expertise for today's lecture. Of course, before we officially end our lecture series for today, we would like to seek your feedback by scanning the QR code presented in our screens, or clicking the link presented in our screen. That would further improve or enhance the delivery of this LaSalle Sustainability Lecture Series. And of course, this would be the last presentation for the year 2023, and we hope by next year we would see you again for a more exciting topics with this lecture series. So with that, thank you so much for your time, and we'll see you again next year.
Thank you.
Bye. Thank you.
Thank
Any
you.
last
Have a
words,
new
Dr.
year.
Thank you.
Aviso?
No, thank you everyone.
Bye.
Happy holidays.
Thank you.
Thank
Bye
you.
bye.
Happy
Happy
holidays.
holidays.
Bye-bye.
I'll end the meeting now.
Thank you.